So the next important concept is activation function. You may already notice that all activation functions are nonlinear, since the composition of two linear functions is still linear. So using linear activation function basically doesn't help. It doesn't help to capture more information. This is why you don't see people use a linear activation function in the intermediate layer. One exception is when the output y is continuous, and you may use linear activation function at the output layer. So intermediate layer and output layer, when you choose activation function, they usually have a different way to choose activation function, a different consideration. And some aspects we can consider when we choose activation function. First is input and output range. The output layer really depends on the response. If the response is from 0, 1, like two-class problem, then you will use the sigmoid, because that will transform the last layer neuron to be a number between 0 to 1. And if it's more than two-class, multiple class classification problem, then you use softmax, because you have more than two classes. So it really depends on the output, so you need to consider input and output range and fit that specific case. You also need to consider the gradient at initialization. If you think about the shape of sigmoid we use at the very beginning for logistic regression, the sigmoid function, you can see the derivative. If z is very big or very small, the derivative will be very small. The derivative will be the biggest when z is around 0. So it's better to initialize the value around 0, and so you have bigger derivative in that case. So that's something you need to consider depending on what activation function you use. That might also impact the way you initialize the variable. And also gradient at extremes. This will help you detect if there's a gradient vanishing problem, that when the gradient gets very small, so the optimization process gets slowed down. And also computational complexity. So if you use hyperbolic tangentless function, the complexity is much higher than you use ReLU, because you need to calculate exponential. Similarly, sigmoid function also you need to calculate exponential. So it will be more expensive than others. So that's another thing you will need to consider. The bad news is there's no one activation function is the best that you use for all the layers. The good news is you can start with the common use case. For many use cases, you might find others already develop a structure of the neural network that works in their data, and your data is somewhat similar. You can try their model and what they use first and go from there. So we already have deep learning has very awesome, amazing community, very supportive, and people will share, people in general will share their code, neural network structure, and their code, the result in GitHub. People build on each other's work. So that's amazing part of the deep learning community. So these are the most common activation function. We already talked about the sigmoid function. Both sigmoid function and this hyperbolic tangent function, they are S-shaped. They have output. The sigmoid function has output between 0 to 1. And you can see the gradient vanish when z gets, absolute value of z gets big, away from 0. Even the fact that the sigmoid is differentiable, that might provide some convenience in terms of backpropagation, but the decreasing shape can cause neural network to get stuck at the training time. That's why now you don't really see people use sigmoid function in the intermediate layer, only for the last layer if it's a two-class problem. So the output layer, you will see people use sigmoid function. Hyperbolic tangent function, this is another S-shaped function. It works better than the sigmoid function as the intermediate layer, but it has a very similar problem of vanishing gradient when z is in extreme. This function cross point 0 and 0, so that's probably why it works a little better than sigmoid function, because in neural network you will see people sometimes centralize and standardize the input. So since this function in some way would centralize things around 0, because it will transform all the data between -1 and 2, 1. But still, it's not commonly used as intermediate layer activation function anymore. It's used the most in recurrent neural network as intermediate layer activation function to polarize the result. And the rectified linear unit function, that's what we used in the step-by-step neural network, one-layer neural network. This is the most common one. It's a groundbreaking advancement in deep learning. It's extremely simple, but it works very well. And then for the ReLU function, if z is all 0, it will cause problem because basically the linear combination for the next layer will be all 0, and then you just don't get anything. So that's why sometimes people use this leaky ReLU. Basically, just for z less than 0, you multiply z with a very, very small number, maybe 0.001, like that, prevent that from happening when z is all 0. ReLU function is nonlinear. Even it's simple, but it's still a nonlinear function. It has the very easy derivative. When z is larger than, for the normal ReLU, when z is larger than 0, the derivative is 1. When z is less than 0, derivative is 0. Or when z equals to 0, you just define it. It doesn't matter. You can define it with either 0 or 1. Like, let me see if I can find the derivative of ReLU. Yeah, ReLU derivative. In application, basically you can say positive z larger than 1, you return z1. And in 0, it doesn't matter. Like here, I just define it as 0. So you can define this point as 0 or 1. To sum up, for intermediate layer, ReLU is usually a good choice. If you don't know what to choose, then start with ReLU. And leaky ReLU usually works better than ReLU, but it's not used as much in practice. So either one works fine. Also, people usually, if you use leaky ReLU, people usually use a equals 0.01. Hyperbolic tangent is used sometimes, especially in recurrent neural network, but you really nearly never see people use sigmoid function as intermediate layer activation function anymore. If it's the last layer which connects to the output, it really depends on the shape of the output. If the output is binary classification, and then you use sigmoid, if it's the output is more than like 2 class classification, use softmax. If it's continuous, you just use y equals to x.